Year 11, here we are with the first video for our third topic, inequations and inequalities. Right, first thing we need to define what an inequation and inequality is. Well, we talk about expressions where rather than saying the left-hand side is equal to the right-hand side, I am now saying that perhaps one of those is bigger. Now, I could say strictly greater than, that's this symbol here, this side, the left is strictly greater than the right. In this case here, right, the left is strictly less than the right. Right, these are the two symbols. Right, this is greater than, left is greater than or equal to the right. The left is less than or equal to the right. Okay, now we use those things. It's an inequality because we're not saying, right, or we're not just saying that they're equal, perhaps. An inequality is a statement that is true for all values of x that are put in there. Right? If I could say that x minus 5 is less than x. Right, if I start with some number and I take 5 away from it, well, I'm going to be 5 units smaller than I was to begin with. Right, so that will always be less than x. Second example here, x squared is greater than or equal to 0. Well, if x is a positive number and I square it, I get a positive number that's greater than or equal to 0. If x is 0 and I square it, well, I get 0, and that's greater than or equal to 0. If x is a negative number and I square it, I get a positive. So that is greater than or equal to 0. Okay, so that is true for all values of x. That's an inequality. An inequation, on the other hand, is only true for some values of x. So maybe x minus 5 is greater than 0. It's not always true. If x were 1, 1 minus 5 is negative 4. That is not greater than 0. Okay, this is only true for some things. This is true when x is strictly greater than 5. Not true for x equals 5. 0 is not greater than 0. It is only true where x is strictly greater than 5. Okay, so that's an inequation. Inequality, always true. Inequation, only sometimes true. Now, we also need to fairly strictly define what we mean by less than. Is negative 2 less than negative 5? It's smaller in magnitude, but mathematically, no, it is not less. Right, geometrically, right, if I've got these two values, the number further to the left on a number line is the lesser number. Right, if A is to the left of B on a number line, then A is less than B. Geometrically, you'll be familiar with number lines. Arithmetically, now this is a bit tricky, it's a bit clever, right, if A is less than B, if B minus A is a positive number. Right, always true, even if they're both negatives, right? If I take away the lesser number, right, then the difference between those is positive. Right? B minus A is positive, means that A is less than B. Quite handy. Okay, so that's less than. That's inequalities and inequations. Let's get into some actual manipulation. Now, dealing with inequations, and that's what we'll be dealing with most of the time here, inequations, I can work with them in the same way that I do with equations, with one exception. With one exception. If I am multiplying or dividing by a negative, then I need to swap the sign over. Usually that's pretty straightforward. You keep an eye out for it. You usually know when you're multiplying or dividing by a negative. Sometimes it gets a little sneaky. Now, I suppose there is something else that's slightly different here. This time, if we look at part B here, this is not just a left-hand side and a right-hand side. I've got 3 expressions there. Nonetheless, we just do the same thing to all of them and it all works out fine. Okay, so let's see how this works. We've got a couple of examples. I want to solve it and I'm going to graph it on a number line. So 3x is less than or equal to x plus 25. Well, normally what I would do here, right, is try to get all of the variables on the left and the constants on the right. So I'm going to say that 3x minus 8x is less than or equal to 25, which would be negative 5x is less than or equal to 25. Now, to finish this off, I need to divide by negative 5. So that swaps the sign over. So that now I get x is greater than or equal to 25 on minus 5. X is greater than or equal to negative 5. Okay. So we swap the sign around because I divided by -5. Now on a number line, right, what have I got here? I need a -5 somewhere. Look, all I'm going to do, put 0 there. I'm going to have -5 here. Now, it's greater than or equal to, so that means I used a closed circle like this. There we go. That is the solution, right? This is everything that is greater than or equal to -5, right? That's what x is. Now, over here, slightly more complicated. Right, what I want to do is, rather than just get variables on the left or something, what I want to do is I want to isolate x on its own in the middle. I want to get x between two other expressions here. So, first thing I'm going to do is take 2 away from each of those terms, right? So, 20 minus 2, I'm going to say 20 minus 2 is greater than -3x, because I've taken that 2 away, greater than or equal to 8 minus 2, right? So 18 is greater than -3x, greater than or equal to 8 minus 2. Oh, sorry, I can write that as 6. Now I divide everything by -3, but that's going to swap the signs over. So I've got a negative sign out here, 18 over 3, right? That's dividing by -3. Swap that around. X over, right, that's just an x, -3 divided by -3. Right, swap all of those things around and I get 6, or let's say -6 over 3, just because I prefer that. Now that's -6 is less than, strictly less than x, is less than or equal to -2, right, and that happens to be in the right way. So, number line, I'm just going to put -6 here, -2 here, and x is always greater than, right? X is greater than -6, strictly greater than. So I use an open circle because it's not equal, it can't be equal to -6, it's got to be greater than that, but it can be equal to -2, and it could be anything in between there, okay? X is between -6 and -2. It can be equal to -2, but it can't be equal to -6. And there's our solution there. Righto. Now, one more thing before this video wraps up, is proving an inequality is false. Right? We've already said that inequalities have to be true for all values of x, not just some, not just a value of x. It has to be true for all values of them. Now, that kind of makes it a bit difficult to prove, right? You've got to prove that it's true for everything. You can't prove something is true in all cases by using an example. But I can disprove it's true for all cases by providing a counterexample, right? If I can find just one example where that doesn't work, then it's not true for everything. It might be true for some things. It's not true for everything. It's not an inequality, right? So you've got to use a bit of creative thinking here sometimes to see if you can find a counterexample. So here's another one. This is going to wrap our video up. 5x, there shouldn't be a full stop there. 5x, oh no, 5x, I've got a problem here. That should be, is greater than or equal to, right? There's a little typo there. I'll have to fix that. 5x is greater than or equal to x for all values of x. Well, that's true sometimes. If x was something like 2, right, then 10 would be greater than or equal to 2. That's fine. But I think here we're going to see that if x is a negative, right? So let's say let x equal -2. Therefore, 5x equals -10. Right, now, -10 is less than -2. Therefore, the statement is false. Okay, that's not necessarily true. 5x is greater than or equal to x for all values of x, not for this value of x, not when x is a negative number. Okay, so we just sort of guessed that one. We found something that was going to work for us, right? And there we go. And we showed that the left-hand side does not have the relationship with the right-hand side that the statement expects it to. Same here. Now, if a is less than b, is it true to say that a squared is less than b squared? Well, in some cases that is true. So let's say if I had 2 and 3, 2 is less than 3, 2 squared is 4, is less than 9. Right? It's strictly less than. But what about, again, if a were a negative number with a greater magnitude than b? So let's say, let a equal, let's say negative, look, we could just go, in fact, let's say a equals negative 1 and b equals 0, okay? B equals 0. Is a less than b? Yes, it is, right? So if a is less than b, right, well, it should be that a squared is less than b squared. For a squared equals positive 1. B squared equals 0. A squared is greater than b squared. Right? Therefore, the statement is false. Right, so either by saying, in this case, a squared is greater than b squared, or 1 is greater than 0. Therefore, right, this is not always true, only sometimes true. Okay, that's the difference between an inequality and an equation. Righto, well, I hope you enjoy this. But jot down any notes, and I will talk about it in class some more. Cheers.